I think the computer's working kind of slow today, but so all we were doing with literal equations when solving them, you're just rewriting them into a variable that it's asking for. So you're trying to look for the inverse operation that occurs with the other variables that are connected to the variable you're solving. So here when we were solving for x, currently showing it was multiplication, so our inverse operation would be to divide both sides by the m. So that gives us the terms x is equal to y over m. And then one more example right here. When we had r was equal to x plus y plus z, and we wanted to get y by itself, that means that all we had to do was subtract x from both sides, and then subtract z from both sides, and we would get y is equal to r minus x minus z. It's just rewriting them into those terms. Here are the other two that we went over real quickly. If we were solving for terms of b, the first thing we'd do is add the r to both sides. So we'd get h plus r. Then we would divide both sides by the a, and then we would get h plus r over a for our value of b. And then, of course, the last one here is very similar to the first one that we did where we're solving for terms of k. We would just divide both sides by p and get x over p is equal to our k value. Okay, again, those are just literal equations. What we're doing now is we are doing word problems, contextual problems, where we are solving for a situation. So what I focused on here for right now is just two-step. Mainly it's two-step equations that you would be solving. You are going to have situations in which you'll have equations that are considered variables on both sides. We'll do those tomorrow. But for right now, we're just focusing on solving those contextual word problems for a given value that they're asking for. You do not have to know how to write the equation out, but I am going to show you how to write an equation out given one or two practice problems, and then I'm going to have you guys do the rest of these practice problems on your own. We'll go over them, and then you'll have your digital assignment. All right, so for here, it costs $12 to attend a golf clinic with a local pro. Buckets of golf balls for practice during the clinic cost $3 each. You can spend $30 for the entire clinic. So you're basically bringing $30 with you to spend for the entire clinic. So we're going to write an equation that represents how many buckets of golf balls be that you can purchase at the clinic. So they're already telling you what variable that you're going to be utilizing here. We know that the maximum amount that we can spend is $30. That means when we're creating an equation, we're creating an equation to equal 30 bucks. So this is what we're setting it equal to. And I'm going to write right above it, this is equals. Okay, so I know when I create my equation, I'm going to have equals $30. Now, it costs $12 to attend the clinic, and then we're going to be purchasing golf balls for $3 each bucket, right? So the only cost up here that's occurring one time is what? The $12, right? The $12 to attend the clinic. Once you get in, you're in. You pay $12 for admission, and then that's it. You don't have to worry about paying any more. That's called our constant. That $12 right here, that is a one-time cost. A one-time cost, which means that it is our constant. When we have something that is reoccurring with our variable value, we call that our coefficient. So here it says that the buckets of golf balls are $3 each. And when we see those keywords each, per, each, and every tend to identify themselves with a coefficient. Per, each, and every identify themselves with a coefficient. And we already know that our variable is B, which represents the number of buckets that we can purchase. That's our variable. So we have 3B, $3 for every bucket that we purchase, plus the $12 for the admission is going to come out to $30 maximum. That's the max that we're going to spend. So there's our equation. Now we're just going to work through it and solve. The first thing that we would do is subtract 12 from 30 and 12 from 12. That's going to leave us with 3B is now equal to 18. And then our last step would be to divide both sides by 3. So the total number of buckets that we could purchase is 6 buckets. Yeah. Huh? Thank you for being smart. Okay. You're welcome. Thank you for being patient. All right, let's take a look at the next one. So Jessica wants to save money so she can buy tickets to a concert. The tickets cost $405, and she's able to save $45 each week as a dog walker. We're going to write an equation that represents how many weeks W is going to take her to solve for enough money for the concert. So do we have a value that we know we're setting it equal to? What value are we setting the equation equal to in this situation? Fatima? Well, that's our variable. We're talking about a value. So when we're writing an equation, so like here we had it set equal to 30. What number value are we setting it equal to, Zachary? 405. That's what she's trying to achieve. That's what she needs to save. She needs to save up $405. So I know when I'm creating my equation, it's going to be $405 is what we're setting it equal to. Now the only other number that I see up here is $45 each week. $45 each week. That term each indicates again that it is a coefficient that's going to be attached to our variable. And what is our variable? W, right? Each week. Weeks W is our variable. So there's our equation. We don't have money already saved. If she had money already saved, like let's say she's like, oh, I already have, $200 in the savings account. Then we would put plus 200 here because that's money that she already has currently and she doesn't have to save that anymore. Okay, so now to solve this, all we would have to do is divide both sides by 45. And we would get W is equal to what value? 9. So W would equal 9 weeks for solving or for saving. Just be mindful that when you're setting up the equations, sometimes you might be adding with your constant, sometimes you might be subtracting with a constant, sometimes you might not have a constant, sometimes you might not have a coefficient other than 1. So what I want you guys to do right now, independently, so we want to see how much you can gather on your own. I want you to do problems 3 through, 10? 3 through 10. Just be mindful. I'm going to flip over to your last page real quick. For problems 9 and 10, they're talking about perimeter. Who can remind us when we say perimeter of a shape, what are we doing for perimeter of a shape? Asia? The outside, right? The outside measurements, the distance around the shape. That means you are adding all sides of your shape together. So if you need to write that down, that perimeter means you are going to add all sides. Make sure you understand that. So if there's a rectangle, you have 4 sides that you are adding. If it is a triangle, you have 3 sides that you are adding. If you are on your computer right now, I'm going to get very upset. So close it. Thank you. Make sure you are working through those problems. So all I've done here is I've just wrote what the equation would look like and what its solution would be. If you have questions about how to solve it, then you can come up and ask me later. But at this point, all of these are just 2-step equations. You should know how to solve 2-step equations by this point. So when we're looking here, he has $145 saved, plus he's going to save $36 each week. So we got $145 plus 36W is equal to $433 that he wants to have saved. When you solve it, you would find out it takes him 8 weeks to do so for number 3. For number 4, she purchased 3 shirts and a pair of jeans. The jeans was $54.99. We don't know the cost of the shirts, but we just know that she purchased 3 of them. The total cost is $140.49. And then when we subtract the jeans and then divide by 3, we'd find out that each shirt is $28.50. For problem number 5, $35 a month for the cell phone plus 50 cents per text message that he would send. This is old school, guys. This is what it used to be like when we first got cell phones. If you wanted to text somebody, you had to pay for every single text message that you sent. So people would always say, just call me instead. So $35 for the monthly fee, 50 cents for every message. How many messages were sent if it was $52 for the month? So you'd get 34 text messages for the month. I think some of you send 34 text messages in like 10 seconds. Number 6, Northbrook Middle School is purchasing uniforms and equipment. The total cost is $912. That's why we set it equal to $912. The equipment was $612 plus $25 for every uniform that was purchased. So that's the equation set up. When you solve it, they're able to purchase 12 uniforms. Let's go on to the next page. For problem number 7, $75 for a plumber just to come out to your house. That's what they do. If you need a plumber or you need an electrician, you need somebody to come out and check out something, they charge you a fee just for them to show up. Then they have a cost that they charge you for how many time or for how much time that they spend there, or the equipment that they're having to use, that sort of thing. So $75 just to get out there, $25 for every hour that they spend doing the repairs. It takes them 5 hours if they were charging $200 total. Okay. For problem number 8, $12 for you to enter the fair, then it's $2 for every single ticket that you want to purchase so that you can ride the ride. So $12 plus 2T comes out to $62 is how much you spent at the fair. That's 25 tickets that you were able to purchase. For problem number 9, it says the length of a rectangle is 11 inches more than the width. 11 inches more than the width means you're taking the width and you're adding 11 inches to it. So here's my measurement for the width, or the length, W plus 11. W plus 11 for my lengths, and then W for my width. So I have everything written in terms of width. So now when I want to write an equation, I know that the perimeter is equal to 82. So that means if I add all of these together, it's supposed to equal 82. So that's where you combine your like terms. I have 1W plus 1W plus 1W plus 1W. That comes out to 4W. Then I have an 11 and an 11 that I can combine together. That comes out to a positive 22. So that's where we get the equation 4W plus 22 is equal to 82. When we solve it, we would get W is equal to 15 inches. Okay? You have to read how they're having you set it up. We've talked about what more than means. More than means that you are adding. You're taking 11 inches and adding it onto whatever the width value is. But we don't know the width value. And then for problem number 10, they at least tell you each of the measurements for the length and the width in terms of x. So the length is 3x plus 4. The width is half of an x. Remember that there's 4 sides, so you have to write these on all 4 areas. When you combine them together, you're taking 3x plus half of an x plus 3x plus half an x. That gives you the 7x. And then you're adding your constants. You've got a 4 and a 4 that you can add together. That comes out to positive 8. The whole thing's set equal to 43. Now, I forgot to write down what I wanted you to solve it in terms of. So in situations like this, you might be solving in terms of x. Or maybe you might be having to substitute your value of x in and solving for whatever the length is, or evaluating the value of the width. So I have all 3 of them written down here. If you solved for x, you should have gotten 5. If you then substituted it back in for the measurement of the length, you would do 3 times the 5 plus 4. That gives you 19. If you substituted it back in for the width, you would do half of 5, which is 2.5. Okay? Your assignment is on Delta Math. You are doing 4 questions for literal equations, and then 5 questions for solving in context unwinding, and 5 questions where you are writing the equation and solving.